Guys, only 8 participants we have here. I'm waiting for more of you to join us so that we can start.
Then we're gonna study a new lecture, or we just review the last lectures.
No, it's gonna be new. So guys, let us start. The audio is okay. I think there is a lag between the video and audio.
Yes, it is.
Salam alaikum. Now, maybe my internet connection is a little bit slow. I'm not sure about that. So, guys, in the previous week, we finished our discussion about various parts of an Eclipse data file. So now at the moment, we should know how an Eclipse data file looks like. We should know the various parts of a data file, starting from run spec and ending with a schedule. We should be familiar with the main parts of each part of a data, main keywords of each part of a data file. And today we're going to continue with a very key topic, which is the topic of zoning. And through learning about zoning, we're going to learn how to actually work with some very important keywords that we usually see in the grid section of the data file that we have. And it lets us be able to do the simulation for some more complex reservoirs. Now, guys, what happened to you? Only 14 participants. That is too low. So I don't know whether or not you're still on a strike, but I have to continue anyway. And at the end of the meeting, we're gonna have a presence and absence. So if you don't want to be considered absent, tell your friends to become online at least at the end of the meeting. Now, so listen. Today we're going to work with let me share it with you. A data file was given to you for which the title was zoning. Right? You should have this data file. The title of the data file is example 2 underline zoning. Right? And the text of the exercise we're going to work on is the continuation of part A of the previous exercise that was given to you. Now, in the exercise it says, let me share another screen with you. So guys, do you have this? It says, very good, very good. Guys, it says, in part A of this exercise, we did the unit conversion, and through unit conversion, we learned the meaning of various parts of a data file and the most important keywords in each part. Now, zoning is the subject discussed in the next part of this exercise. What does it say? It says, do these changes to the data file that we already have. Change the grid to 5 blocks in the y direction with dy equal to 100 meters. So our reservoir is going to be stretched into the y direction for 500 meters, right? And the two topmost layers should be 10 meters thick and the lowest layer 20 meters. Okay? So the thickness of the various layers that we have also changes. There's a heterogeneity on that front also. Now, after reading this, let's go back to the data file and see how we're going to write that into our data file. Now, so in the run spec section, we are going to need to make some changes. It says, instead of 3 blocks in the y direction that we had previously, now we're going to have 5 blocks in the y direction, right? So here we should make one small change in the previous data file that we had, and it is the change that we need to make in the keywords dimensions, right? Now the dimensions of our reservoir has changed from 10.3.3 to 10.5.3. So this second field in this keyword has to change from 3 to 5. Okay, now what are the other changes that we need to make? The length of each cell in various directions also has changed. The length of each cell in the y direction has changed from 305 meters to 100 meters, right? In the original data file that we had, the length of each cell was 1000 feet in the y direction, 1000 feet in the x direction, and around, I don't remember how thick it was in the z direction, but doesn't matter. Now, in the y direction, the length of each matrix block was 305 meters. Now, the exercise tells us to change it to 100 meters. But that is not the only change that we need to make. The number of cells that we have also has changed. Now we don't have 90 cells. Now we have how many cells? 10 times 5 times 3, which is 150 cells. Okay, so in each field and in the process of writing the proper data for each keyword, we have to input the data for 150 cells instead of 90 cells that we previously had. So for dx, what should we enter? The length of each of the matrix blocks in the x direction. We have 150 cells. For each of them, the length is 305 meters. So here we write 150, which is the number of cells. Please look at the screen. 150 cells, and for each cell 1000 feet or 305 meters. Yes? We need to do the same that we did. We need to do the same thing for the y direction. Now, for each cell, we have to specify the length of the cell in the y direction. 150 cells we have, and for each of these cells, the length in the y direction is 100 meters. So we have to write dy, and after that 150 times 100, and we have to terminate it with a slash. Now for dz, we also have to specify the length of matrix block, the length of cells in the z direction. Now we have to write the data for 150 cells, right? 150 cells. How do we do that? Look, here you see this 100 times 10. Please pay attention, everybody. This part is very, very important. Now, when it comes to the keyword dz, like every other keyword in the grid section, we have to write the data. We have to write the data for 150 cells. Okay? What? What is going on? Did anybody have any question? Go ahead if you had questions. So, I was saying, when it comes to this keyword, like every other keyword in the grid section, we have to write the data in front of it. Look at the screen. I have to write the data for 150 cells, right? I have to write the data for cell number 1, for example. I have to write a piece of data for cell number 2, a piece of data for cell number 3, right? A piece of data for cell number 4, and I have to do that for every cell up to the cell number 150. Okay? Now, we learned that we can circumvent this tedious process by using this star. When we write 100 times 100 star 10, which is 100 times 10, it means that the DZ, or the value of whatever this keyword is, for the next 100 cells is equal to 10. Yeah. Thank you for turning your music off. What?
Now, last week you told us that lecture will start at 10 o'clock, not now. And most of the students are now in Moscow.
Last week we started at 9 p.m., right?
Yes, but you told me just last week we start at 9. But we have scheduled for 10 p.m. every week.
No, the subject of discussion was for only 1 week, right?
But I emailed the first email that we start at 10, and you told me it's okay.
That was for the previous week, right? Now, anyway, we have started, and most of you are here, so let us continue. If
Most of them are not.
so, tell them to become online. Now we have started. What can we do? You are right, Jamal. We had to start 1 hour later. Huh?
I'm talking about the attendance list.
So you have to tell them to become online, because we are going to take presence and absence at the end of this session. Okay? Because of that, we're going to do the presence and absence at the end of the session instead of at the beginning. Okay? And you are right, Jamal. I forgot that. Because in Iran time, it is 9 p.m. of Iraq time becomes 10:30, and I forgot about the timing. The time difference between Iran and Iraq got me confused. Yeah, you are right. We were supposed to start at 10 p.m. Yeah. Anyway, we have started. Let us continue. Okay. And this is being recorded, and it is going to be sent to you. Now, so Jamal, please tell them to to be online for the presence and absence at the end of this meeting. Okay? Now,
Recording?
we are recording, yes. And I'm going to send you the recording. Now, guys, this part is very, very important. Now, when we write 100 star 10, it means that I have the data equal to 10 for the first 100 cells. Okay, that is the meaning. And when I write 50, look at the screen please. When I write 50 star 20 or 50 times 20, it means that for the next 50 cells after these 100 cells, the value of dz is equal to 20. Now guys, everybody understood this? This part is very, very important, and one of the questions of your final exam is going to be this. Soham, Soham, you have lots of noise. Your microphone has lots of noise.
Okay, you mean for 100 seal the dz is equal to 10?
Soham Gyan, please, please.
Said for the 100 cells, dz is equal to 10.
Yes, for the first 100 cells, the dz is equal to 10, and for the next 50 cells, the dz is equal to 20.
Do you give the information or you have to find these good values?
No, the information is going to be given to you, but not in a straightforward way. How is it given to you? Look, let me share this screen with you. Look, this is the text of the exercise. Okay? Look, here it says, change the grid to 5 blocks in the y direction. Okay? And we know that we are doing modifications on the previous model. And in the previous model, dx was equal to, it was 1,000 feet. We had 10 cells in the x direction, 3 cells in the y direction, 3 cells in the z direction, right?
Yes.
Now, we changed the dimensions so that we have 5 cells in the y direction. So what is the overall number of cells?
5 multiplied to 3 multiplied to 10.
Ahsan. Thank you. 150. So, for dz, like any other keyword in the grid section, I'm changing the screen. For dz, we have to write the data for 150 cells.
Yes.
But we don't, Shahir, thank you. But we don't need to write 150 separate pieces of data. We can use this multiplication, and this means that for the first 100 cells, dz is equal to 10. For the next 50 cells, dz is equal to 20. Now, how do we know that dz is equal to 10 for the first 100 cells and dz is equal to 20 for the next 50 cells? Let us go back to the text of the exercise that we have. Okay? Now I'm changing the screen again. Shahir, are you paying attention? Look. Thank you. It says, how is it given to us that what is our dz? It is given in this way. It says the two topmost layers should be 10 meters thick and the lowest layer 20 meters. So the thickness, the thickness for the first layer and the second layer is 10, and the thickness for the third layer is 20. Okay? Now, in the first layer, how many cells do we have?
2 multiplied to 15.
10 multiplied by 5.
Yes, in 100 cells.
Exactly. In the first two layers, we have 100 cells. So the dz for those 100 cells is equal to 10, and the dz for the next 50 cells that we have in the third layer is 20. Understood?
Yes, sir. Thank you.
Good. This is a very important thing that you need to know when you're working with Eclipse. Very, very important. This is how the code writer of Eclipse decided to write the keywords. Okay, this is not a law of physics, this is not a law of mathematics, this is just a convention. The code writer of Eclipse decided to write the code in this way. So you should know how the software works. There's no other way. And all of this stuff that I'm talking about is written in the reference manual of the software also. If you want to have additional information about this, you can always go, and you have to always go to the reference manual. Now, let me admit your friends here. Now, so this was a very important piece of knowledge that we needed to have. Now, guys, let me ask you a very important question. And the answer to this question that I'm asking is the key for understanding the keywords in Eclipse. Let me change the screen. Now, look. Guys, please pay attention and look at the screen. Now here I said this. I was writing dz equal to blah blah blah. And I said for the first 100 cells dz is equal to 10, and for the next 50 cells the dz is equal to 20. Now question, how do I say that this, for example, if this is my reservoir, how can I say that this specific cell is the first cell and that specific cell is the last cell? How can I know which cell is the first, which cell is the last?
There, I think the first one that I writing is the first cells in the left side.
But how do I know which is the first cell in the left, on the left side? Left side, if you look at it, if it is the y direction, there's one way to write it. If it is the x direction, there's another way to write it. Which one should I choose?
No, I don't know.
That is an important question, and you are not supposed to know. We have to read the manual of the software, and over there it tells us. Now guys, because this subject is very, very important and there's only 8 minutes left, let us have a small break and come back after the break, and we're going to continue this. Okay? So I'm going to finish this, and I'm going to send you another link. So guys, please pay very close attention. This part of our discussion is very, very important. Now, where were we? Let me share the screen with you. Now, the question that we are asking here is, yes, here after each keyword like DZ, we need to input some pieces of data for all the cells that we have. But first we need to enter the data for the first cell, then for the second cell, and we have to continue on till we reach the last cell. But what is the order of cells in the model that we have? That is the question. How do we order cells? Okay? That is our question. How do we order cells? Everybody understands what is the discussion? Please pay close attention. This part is very important. Now, to answer this question, let us go to the flow viz and see the actual reservoir that we have. Over there, I'm going to give you the needed explanations. Now, let me close these tabs so that we can reach to the desktop.
Record this video.
Yeah, we are recording it. So, now I'm going to go to flow viz. Okay? So, I'm opening up flow viz. Now hopefully you are seeing the flow with, right?
Yes, sir.
Very good. Now I'm opening up the simulation for this data file that we were working on. Example 2 underline zoning. Now guys, please look at your screens and pay close attention. Now, here you see here you see three axes. The x-axis, the y-axis, and at the bottom you are able to see the z-axis here, okay? And for the moment, don't worry about these missing blocks here, okay? Try to ignore them at the moment. And look at the screen. Now, follow the pointer, follow the cursor that I'm working with. Now, I go to this block, to this cell, and I click on it. Now, please look at the bottom of this flow with section. Now, for this cell, the data is written at the bottom of the flow with on the left hand side. What does it say? It says 111 and under the parenthesis 1. These three numbers are the x, y, and z coordinates of the cell that I clicked on, and after that I have the number of the cell. Okay? Now, let us click on this cell that I'm pointing at, which is the cell with 1x added to the coordinates of the previous cell. Now I go to the bottom of the flow with on the left hand side, and for that cell I see 211, which are the coordinates, and then the number for the cell, which is 2. Do you see here? Do you see the number of the cell here?
Yes.
Very good. Thank you, Sayyaf. Now, again, look at the screen. Look at the screen. And now I am pointing at this cell for which I have y. It is next to the first cell, but y is added. Y has increased. Now I'm clicking on this cell. Now look at the number that I get at the bottom of the flow with. It says that the number of that cell is 11. Right? Do you see this? The number 11 here? Very good. So guys, pay close attention to the screen. This cell that I'm pointing at is the first cell. Now, this cell that I'm pointing at is the second cell. But this cell that I'm pointing at is the 11th cell, right? Now, that is the 11th cell. Why do we have this system of numbering for the cells in the Eclipse? Why is that? The convention in Eclipse is that if we want to number the cells, we start at the cell number 111 and we consider that cell as our first cell. Then what do? We increase the coordinates in the x direction and we number the cells by increasing first their x coordinate. Now this cell is going to be our second cell, as you can check with the bottom of the flow ways on the left hand side section. This cell is going to be our third cell. This is going to be our fourth cell. This is going to be our fifth cell, sixth cell, seventh cell, eighth cell, ninth cell, 10th cell. And when we can't increase the x direction, then we increase the y direction. Okay? So, after this 10th cell, we go and increase the y coordinate with 1 unit, and this is going to be our 11th cell, and we continue like that. This is going to be our 12th cell, 13th, 14th, 15th, 16th, 17th, 18th, 19th, 20th. Okay? Then we go back and increase the y direction with 1 unit and then keep increasing the x direction. Okay? So this cell is going to be, guys, pay attention to the screen. This cell is going to be our first cell, the cell that I'm pointing at. And this cell is going to be our 10th cell, because we have 10 cells in the x direction. This cell is going to be our 11th cell. This cell is going to be our 20th cell. This cell is going to be our 21st cell. This cell is going to be our, can you tell me? 13th cell. Great, Shahyar. Thank you very much. This cell is going to be our 31st cell. This cell is going to be our, Shahyar, 14th. Exactly. This cell 41st. This cell 50th. Right?
Right.
So, first we increase the x direction. When we can't increase the x direction at all, we increase, sorry, I keep saying direction. First we increase the x coordinate. When we can't increase the x coordinate anymore, we increase the y coordinate with 1 unit, and then we keep increasing the x unit again, and we keep doing the same until we can't increase the y unit also. Then what do? Then we increase the z direction, z coordinate. What does that mean? It means that we move to the second layer. Okay? Now, look, I want to show it to you here. Here I don't have access to the second layer. In order to do that, I go to IJK slicing, scene, grid, IJK slice, and here for the kth slice, I click on 2. Now I'm going to see only the second layer of my reservoir. Okay? So now here I have access to every cell in the second layer. Now let us do this. Now I click on this cell. What is the number of this cell as I expect? What is the number that I expect for this cell? Thank you very, very much. 51st. As you can see here. What about this? 60th. 61 here, 70 here, 71 here, 80 here, 81 here, 90 here. Exactly, thank you. 91 here. Here what do we have, Sherban? 100, right? And just like that, we can move on to the third layer. If there is a fourth layer, we can continue like that. Okay? So, the rule is, first I increase the x coordinate as much as I can. When I can't do that, I increase the y coordinate and then increase the x coordinate. When I can't increase the y coordinate also, I increase the z coordinate.
Okay.
Very good. Very good. This is the main piece of knowledge that you need to have in order to do the zoning. What do I mean by zoning? Please pay close attention. I have a reservoir like this. Let me undo the IJK slice that I've done. Now, maybe guys, maybe my reservoir looks like this. Maybe some cells are missing here. Maybe in my reservoir there is maybe the first layer is a very high permeability layer. Thank you. Mutşekkir. Maybe the second layer is a low permeability layer, and maybe in the third layer some blocks are missing. So we might have different zones in our reservoir. And in order to address the properties of various zones, we need to be able to input the proper pieces of data for various keywords. And for doing that, we need to be able to identify various zones clearly and specifically. And these numbering of cells helps us do that. Now, متشکر. Now, guys, let us go back to the exercise that we had. Please open up the Word file. Let me share a different screen with you. Now, here, what does it say? Please look at the screen. and check out the Word file. In this part of the exercise, it says for the porosity, we have three different regions. A region with high porosity, a region with low porosity, and a region with zero porosity. Right? Now, the zero porosity happens where? It happens in the box I from 4 to 7, J from 1 to 5, and K equal to 3. Right? Now, if you look at the flow with having zero porosity means that we have no oil saturation. So when you want to see this property, which is oil saturation, the third layer, some part of it is going to be missing. Look at the data, look at the exercise. In the box I from 4 to 7, J from 1 to 5, and K equal to 3. And now look at the flow with. Let me change the screen. So here I'm only showing the third layer. Now, you see that here, and let me change the property also to porosity. So, do you see this? The porosity is equal to 0 for the cells for which K is equal to 3, meaning we are in the third layer. I is equal to every number from 4 to 7, and J varies from 1 to 5. So it stretches all the way along the y-axis, right? This is why this part is missing. Okay? This is our zero porosity region. Now, let us go back to the exercise. There is also a low porosity region in the second and third layer. For it, I is equal to 8, 9, and 10, and J is equal to 2, 3, and 4. And the rest of the cells have high porosity. Okay? And in the high porosity region, the porosity is equal to 30%, and in the low porosity region, the porosity is equal to 20%. Okay? With keeping this in mind, that we have these three regions, high porosity region, low porosity region, and zero porosity region, we go back to the data file. Let me share the,
For those properties such as permeability, is it the same?
no, the permeability also changes. Look at the exercise. It says what? For the high porosity region, permeability in the x direction is also equal to 800 millidarcies, and for the low porosity region, perm X also is equal to 70 millidarcies. Okay,
Okay.
very good.
But can you share the screen with us?
The exercise,
Sorry, your sound is not good.
sorry, it is the quality of internet. It is low tonight.
Can you share the screen with us?
Which screen, Shervan?
Word screen.
The exercise also.
Okay. Now, here you see that in the high porosity region, this is what happens. The low porosity region, this is what happens. Now, this affects every part of the code that we're going to write, especially in the grid section. Okay, now can we go to the data file?
Yes, teacher.
Very
So
good.
it's permeability from the X direction.
What, Shahyar?
The permeability 800 is the permeability from the X direction only, or
No, it is perm X. You have permeability in the X direction for every cell. Huh?
every single the X direction. Okay.
Right. Every cell has 3 permeabilities in the X direction, in the Y direction, and in the Z direction. But here it says that the permeability in the X direction is equal to this, and then it says permeability in the Y direction is equal to the permeability in the X direction, and the permeability in the Z direction is equal to 1/10 of permeability in the X direction. Okay?
Okay.
Very good. Now let us go back to the data file, see one important small thing, and then the discussion for this week is over. Where is the data file? Let me find the data file. There's only 10 minutes left of this lecture. Quick. Now, guys, look at this part of your data file. In the first layer we have 50 cells. In the first layer we have 50 cells. And every cell in the first layer belongs to the high porosity region. So we have no problem on that front. No problem at all. Every cell is the same in the first layer. After dealing with the first layer, we have to deal with the second layer. But in the second layer we have a problem. Some cells belong to the high porosity region and some cells belong to the low porosity region. Right? So for the second layer, how do we need to write the data? That is the question. Now look, this is what you see here. 10 cells with the high porosity regions property, and after that 7 cells with the high porosity regions property, and after that 3 cells with the low porosity regions property. So we write something like this: 10 high, 7 high, 3 low, 7 high, 3 low, 7 high, 3 low, 10 high after that, which gives us 50 cells in the second layer. This is the answer. But how do we reach to this answer? Let us go back to the flow with. So keep this in mind. With having this in mind, let us go back to the flow with. Now guys, please pay very close attention to the screen. This is what we have in our second layer, right? Now in the second layer, still look at the screen. These first 10 cells in the second layer belong to the high porosity region. After that, in the second row, the first 7 cells belong to the high porosity region, and the last 3 cells belong to the low porosity region. And that is what we write in our data file. Look. In the second layer, 10 high, 7 high, 3 low. And in the next row, 7 high, 3 low. In the next row, 7 high, 3 low. And in the last row, 10 high. Okay? Let us go back to the flow with. So guys, let us go back to the flow with. Now, here for the second layer, we write the property for various cells by considering their order. For the first 10 cells, every cell belongs to the high porosity region. For the next 7 cells, every cell belongs to the high porosity region again. After that, we have 3 cells belonging to the low porosity region. And then 7 cells for the high porosity region, 3 cells for the low porosity region, 7 cells for the high porosity region, 3 cells for the low porosity region. And at the end, 10 cells for the high porosity region. Okay? That is how we write the properties for various cells, by considering their order. This is how we use our knowledge of the order of the cells in our model. Okay?
Okay.
Very good. Guys, we have to continue this discussion in the next week. Now let us do presence and absence, and after that, that is it for today. So, Ibrahim Khosro, very quickly. Asu, Araz, are you here? Iman, I saw Iman. Barzan,
Yes.
Bushra, Jamal, Tro,
Yes.
Tro, absent. Khatun,
Now the Wi-Fi.
اوکی. خاتون
Yes.
رسمیه. آیسا رسمیه. ریباز آیسا ریباز. زانا آیسا هم. سازان سازان are you here؟
Yes, yes, yes.
اوکی. سالار
Yes, Ustaz.
سالار is here.
I
اوکی.
am Zana.
اوکی زانا. سروه سروه. سنوبر
Yes.
very good. سربست سوران سوهام سیداد سینان آیسا سینان
Yes.
شکیلا شکیلا is here. شکیلا شهیار شوان شروان شیواز شیما
Yes. Yes, sir.
سیاف آیسا سیاف عبدالله
Yes.
عبدالله عزیز آیسا عزیز فرهاد
Yes.
فرهاد فرهاد absent. کیفی are you here؟ کوسار گوند محمد احمد محمد سیامند محمد امین محمد حسن مهبست هدیه هوراز
Yes.
وینا یاسر محمد جواد دنیا